Hello students, I am Sachin Prakash and I teach and mentor students in chemistry for IIT. I believe that the real confidence which is required to crack this IIT exam will come only when you are confident in tackling good problems. And that clarity and understanding of concepts will only develop when you are really comfortable in handling these problems. So this video contains the paper discussion which I have conducted in my uh, classes online. Okay, and a lot of good doubts are there which I have discussed here. It will be helping you people in understanding, developing an understanding in how to approach and tackle good problems. Okay, and if you like this, if you found this paper discussion video to be useful and interesting, you can, like, comment, and subscribe to this channel, which will surely, motivate me to add some more useful videos of this type. Okay, because ultimately it's, this is just an effort, honest effort, small honest effort from my side to help the student, uh, help my students as well as other students also in their ITJ preparation. So let us begin with this paper discussion. Okay.
So now we are live. Today we are going to discuss WTM 22. This is a means-based paper and first 20 questions are single correct type. This is the paper in front of you. Okay. And the last 5 questions are numerical value. So as usual, we are starting with a numerical value type questions. So question number 71, 72. Any doubts? 71 and 72.
72, sir.
72.
Yeah. See, ozonolysis, if you're not doing reductive ozonolysis, this means that it will give COH. Are you getting a point? Yes or no? It means it will be oxidized to carboxylic acid. So here, the terminal alkene and the terminal alkyne plot will be giving CO2. Are you getting a point? Yes or no?
Yes, sir.
So answer is 2. Okay. 73, 74, 75.
74, sir.
74.
Sir, 71.
71. What's the problem with 71? See, it is giving ethanoic acid. This means it is giving something like this. Now this is coming from which alkene? Something like this. And there is only one alkene, one product. This means that this part should also be CH3, CH3. So your product is, your alkyne is this but2-wine. Okay. So its degree of unsaturation is 2. So you have to write the ring chain isomers. So basically 4 carbon with a double bond. Okay. Then 4 carbon atoms with 2 rings. Then you can have 3 carbon with a double bond here, a double bond here, a double bond here. The answer is 5. Is it clear?
Yeah, okay, sir.
73, 74, 75, 74. How much long did this physics paper discussion went? 1.5 hours. Yes, no.
1 hour 45 minutes. Sir.
Was it a lengthy paper?
Physics paper discussion is always like that, sir.
Okay, so always like that. Okay. So I have 2 wine on HBr addition. So this is like plus, sorry, minus, this is like plus. Okay, so you will be getting PR on H. Okay, yep, 2. Okay, number of COSMS, 1 equivalent of HBr. Is it 1 or 2? 1 minute. This is CHBr. Okay, they are considering both the cases. Because this is the, what do you say, as major product. Because you see here only the minus I effect, plus I effect could be stabilizing the carbocation. So, but you can also have what you call as the minor product, where Br is something like there and hydrogen is something like there. So this will have E plus Z. This can also have E plus Z. So the answer is 4. Is it clear?
Yes, sir.
Okay. After this,
75.
75, the answers will be 1, 2, 3, and 4. Tell me which one do you want me to discuss? 1 and 2
The
will
fourth
be
one.
are similar, 3 and 4 are similar. Which
So,
one?
once can you explain fourth one?
Fourth one. Okay. Third one is clear?
Yes, sir.
If third one is clear, then fourth one should also be clear, no? Because it is the intermediate step. See, when you're doing H plus, first this will be OH2 plus and this will go out. You'll be getting CH2 plus. Then what will happen? The alpha card, this group will be migrating like this. So you'll be getting 1, 2, 3, and 4. So you'll be getting 1, 2, 3, and 4. Okay, so the plus charge will come on the first carbon. Third carbon is carrying the CH2OH. Second carbon is also containing CH2OH. And this is H plus. So what will happen that it will lose an H plus and you'll be getting this. Are you getting a point?
Yes, sir.
After that, what will happen? Again, one of the H plus will get protonated. Let us say this one. This will go out. CH2 plus. Always this group will be moving. Okay, again, if I am taking 1, 2, 3, 4, 5, you'll get 1, 2, 3, 4, 5. At the first carbon, again, a positive charge will come. Okay, it's like this one is moving. So, the first carbon, the positive charge will come. There will be a double bond between 2 and 3. Okay, then fourth carbon is having an OH group, and this is having a hydrogen. You lose an H plus and form a conjugated diene. Are you getting up to this? Yes or no? Again, H plus will convert this to OH2 plus. This will go out. You will be getting CH2 plus. Again, what will happen? This time, one of this group will be going on. Okay, if I'm writing it as 1, 2, 3, 4, 5, this is the sixth one. Then you'll be getting 6. Okay, positive charge will come on the first carbon. Okay, and there's a bond between 2 to 3, 4 to 5, and there's a hydrogen here. Lastly, this will go. You'll be getting this as benzene. Is it clear to all of you? Yes or no?
Yes, sir.
Yes, sir.
Similarly, the fourth one is this one. So this will also give benzene. Are you getting this? Yes or no?
Yes, sir.
Yes, sir.
That's it. 75 is done. Okay. So no doubts in 71 to 75 now?
No, sir.
Okay, then moving up. 68 to 70.
69, sir.
69, I have told you that first you will be getting C2H2.
Sir, it's not anti-aromatic.
Okay, so C2H2 you will be getting if you are treating calcium carbide with water. Okay, I think the reaction will be something like C triple bond C minus minus HOH. We'll be getting C triple bond C H and H. Now you are treating 4 moles of this with NiCN whole 4. I have told you that this will lead to polymerization, and you will be getting what? Have I given this reaction in the notes?
Yes, sir.
Okay, so the answer will be cyclooctatetraene. Is it clear? Yes or no?
Yes, sir.
Okay, so the compound will give bromine water test because these are like non-conjugated double bonds. It is anti-aromatic in nature, is incorrect. Degree of unsaturation is 5, not 4. It will give bromine water test. It does not have high resonance energy because it is a non-conjugated molecule. It's a non-planar molecule. Something like this, right? So the double bonds are not in the single plane. Are you getting a point?
Yes, sir.
Okay, so 69 is done. Next is
70.
70 is a doubt. Why? It is asking which reagents
Sir,
cannot be
Zn
used.
dust, what does it give, sir, generally?
Zinc dust will be give. Zinc will give electron. This electron will attack here. It will cause dehalogenation. This will go like this, and this will go out. Are you getting a point?
Yes,
Zinc
sir.
dust or zinc acetic acid, these will be giving dehalogenation. Similar thing will be given by magnesium also, or sodium iodide in acetone also. Are you getting a point? Yes or no?
Yes,
Yes,
sir.
sir.
Okay. Then 66, 67.
66, sir.
Physics class is still going on?
No, sir.
Some people are saying it is still going on. Anyways, okay. Those who are missing can see the video on YouTube later. 66 and 67, which one?
66, sir.
66. Okay, just one minute. Okay. Mm, 66, yeah. So it's like bromohydrin. I think here they are missing an oxygen sort of thing, but still. You see, you have 5, say, triple one CH, and you are reaching Br plus and OH minus. What will happen? That this will be attacking here. Will be getting faster cyclic bromonium and yes or no? But you see, this is benzene, so positive charge should be more stable here. So the H2O will be, the OH minus will be attacking from this side only. So you're getting 5COH, double bond C, Br and H. And twin remains finally it will be giving 5C double bond O, CH2, Br. So the answer should be none of these. But they are saying that, okay, okay. They are using two equivalents. So after this, you see HBr addition, Br2H2O. Okay, this will be giving actually what you call as alpha halogenation of ketones. Are you getting a point? So what will happen is that this will again, this form, if Br2 is available, then this form will again attack bromine and this will leave out. So you'll be getting 5C OH C Br H and Br. Are you getting a point? Yes or no? Now H2O will be again attacking this because delta plus is more stable here and this is 4 like this. So you'll be getting 5C OH OH C Br H and Br. This will be used 5 C double bond O CH Br2. Are you getting a point? They have mentioned two equivalents. Is it clear? Yes or no?
Yes, sir.
Okay. After this, no other doubts in 65 to 67.
Sir, what does like decolorization of PR2 mean?
Means bromine is reacting with something. So its brown color will disappear.
Okay, sir.
Okay. This
Yes,
is,
sir.
this is clear to all of you? All the questions 65 to
Yes,
60.
sir.
Yes,
Okay.
sir.
Yes.
62 to 60, 63, 64.
Sir, 62, why
62,
not
sir.
option A, sir?
Is 63, 64 a
Sir,
problem?
62, 3, no, sir.
62, I am saying these two. Is there an issue?
Sir, 65th.
63. P2 catalyst will be leading
65.
syn hydrogenation of hydrogen across an alkyne. So you'll be getting this also to be cis. Okay. Easy. If you see this, it is trans. Here it is cis. Here it is trans. Here this is not possible. Answer is option 2. Are you getting a point? Yes or no?
Yes, sir.
Sir,
P2
I asked 65.
65. Yeah. So you see this is going to give dehalogenation. So this Br and this Br will go first. So you'll be getting R, C, Br. Okay. Double one C, Br, R. Since you are using excess of zinc, it will finally give RC triple bond CR. Okay, it is giving minus Z and Br2. Are you getting a point? So X is something like this. Now, if you are using PD-D2, it will give you like a syn product. And if you are using NaND3, it will give a trans product. Are you getting a point? So this and this, Y and Z, are what? Geometrical isomers or diastereomers. Are you getting a point?
Yes, sir.
That's very good. 63, 64 is done. 61, 62.
62, sir.
Yeah, 62. This I have given in the class also, no? In this
Sir,
case,
C6, H5COH will give no benzene, no, sir.
in this reaction, see, even
Yes,
if
sir. Once explain that reaction, no, sir.
it is decarboxylation, even if you are using 5COH on reaction with NaOH, it gives this only. Then it gives 5 minus, which we will taking. Are you getting a point?
Yes, sir.
Okay. You are not supposed to mug up everything. If you have followed the reaction mechanism, it will be easier. Is it clear? Okay.
Yes, sir.
So can you give the product for fourth one?
Fourth one will not react with AlCl3.
Okay, sir.
Alkanes do not react with AlCl3. 61 is not a doubt.
No, sir.
59, 60.
No, sir.
No doubt, sir.
58.
No, sir.
No, sir.
Okay, just one minute. Can you? So 58 is not a doubt.
No, sir.
No, sir.
Okay. Then 56, 57.
57, sir.
Okay. This is a reaction which we have discussed in the class. That if you are having this type of reaction, then it will lead to formation of chloroprene, right? See what will happen. Cu2 plus will be reacting with the triple bond, and you'll be getting CH2 double bond CH, single bond C, double bond CH, Cu plus. Okay, this will react with Cl minus, and you'll be getting. Did I discuss this reaction on the last day of alkyne class? Okay, then it will lose this as minus Cu plus. It's Cu plus, not 2 plus. And you'll be getting CH2, CH, C, Cl, double one CH minus, and this will take the H plus, and you'll be getting. Is it clear? So you look at a chloroprene, which is a monomer of synthetic rubber. Are you getting this one?
Yes, sir.
Okay. Next. 55, 56.
No doubt, sir.
I think you can do these type of questions now.
Yes, sir.
Yes, sir.
Okay. 53, 54.
No doubt, sir.
53, sir.
53, sir.
53.
So 53, I have told you that this will give vinyl acetylene because there are two moles. Do I need to write the mechanism or do you remember it?
So once can you show the mechanism also?
Okay. So see what has happened at first. Cu2 plus Cu plus will be attacking the acetylene part, delta minus delta plus. So we're getting HC, one CHCU plus. This is an electrophile. It will attack another acetylene molecule. So sorry. So you'll be getting HCCU double bond CH H double bond CH plus, right? Okay, and then what is going to happen is that this triple bond will come back. You'll be getting HCCU double bond CH single on C triple bond CH, and last step this Cu plus will go out and you'll be getting, see, CuCl here is acting as a catalyst. So at some point of time, it has to leave the molecule and form this thing. And then this is going to take an H plus from an H4Cl and form CH2 double bond CH. C triple bond CH. This is vinyl acetylene. I have told that this hydrogen is now replaced by a vinyl group. Is it clear? Yes or no?
Yes, sir.
Can you do the other steps or do I have to do that also?
We'll do it, sir.
You can do it? Okay. 53 is done. Then 51, 52. Any doubt? All are very straightforward questions, right?
Yes.
51 to 54, is there any doubt? Yes or no?
54, sir.
54. Yeah. So you see, in 54, you have got something like this. Okay, RC triple bond CH. R is this group. Okay. So if you're using NaNH2, what is going to happen? With RC triple bond C minus, then what is going to happen? You have R dash X. R dash is what? R dash is CH3CH2. So what will happen? This will attack here and this will go out. So you're getting RC triple bond C, R dash. R is also ET and R dash is also ET. I'm writing it like this. C2H5, C triple bond C, C2H5, and lithium and NH3 It will give Birch reduction. So the hydrogens will be coming what? Anti to each other? Yes or no? So the answer should be option number 3. Are you getting it? Yes or no?
Yes, sir.
Okay. Any other doubt in this paper? Whole paper? Yes or no?
So in 51 first reaction, can you explain?
Yeah, that I can explain. Okay. CH2 double bond C turn CH2. Okay. So what is going to happen is that you have H plus. Okay. So the polarities will be something like this is delta plus and this is delta minus. Okay. So what is going to happen is that you'll be getting something like CH2 double C CH3 plus. Now this is getting what you call as hyperconjugation stabilization. Are you getting a point? Through this CH3. Are you getting a point? Yes or no? And then H2 is going to attack here. And you'll be getting CH2, C, OH, CH3, and then you'll be getting CH3, C double bond O, CH3. Is it clear?
Yes, sir.
That's it. Any other doubt in this paper?
Sir, 68 ones, can you explain?
Yeah. See, this is simply isomerization reaction. If you're using alcoholic QH, then it will change to terminal alkyne. Something like this will be CH, a triple bond will come here. And if you're using NaNH2 paraffin, it will come here. So A and B will be positional isomers. Are you getting a point?
Yes, sir.
Okay. Any other doubt in this paper?
Sir, 59.
59. 59. Yeah. C5H8 on treatment with AgNO3 gives white precipitate. This means it should be a terminal alkyne. RC triple bond CH. Now on treatment with cold alkaline KNF4, what will happen? This will break down. You'll be getting CO2 plus RCOH. This is the R group. R is isopropyl group. It is something like this. Getting a point?
Yes, sir. Okay.
Any other doubt in this paper? How was the maths paper? Easy. Is this paper
Moderates.
tough, moderate, or easy?
Moderates.
Still moderate. Why? Because you people have made mistakes. Yes or no? After discussion, are you feeling that this is any toughness in this paper? Because this reaction I have discussed, this also I have discussed. Whatever doubts you will have asked. This one, the first one, only that you can think of, because I have told you that the most substituted carbon should be getting the delta plus charge. Okay, you can do it from that also. But anyways, so is there any doubt in this paper which can be discussed? Yes or no?
No, sir.
Okay, if there are
No,
no
sir.
doubts, then can we? So then, I think can we end this paper discussion now? You have anything to ask? I'm just closing the paper. Okay, so today we are going to discuss WTA 22, which is advanced based paper on alkynes mainly. Okay, and this is a paper in front of you, consists of 3 sections. Section 1 is like multi-correct type with 1 or more options. Section 2 is numerical value type, and section 3 is match the following. Okay, so we'll be starting with section 1 first, okay, which is the multi-correct answer type. So question number 19, 20, 21 and 22. Any doubts?
So 19 option D.
Option D. You see, sodium acetylide reacts with tertiary alkyl halide to form alkene as a major product. You see, suppose I am having, okay, this type of thing, and I am having, like C triple bond C minus, any base for that matter, okay, any base you are having, and you are having a 3-degree halide. Now with 3-degree halide, elimination is preferred over substitution. Is it clear? Okay, I have given this point in the class also,
Yes, sir.
that for 1 degree and methyl halide, SN2 is preferred, with 2 degree and 3 degree with base. See, with base, you will have the bimolecular mechanisms, either SN2 or E2. So with 2 degree and 3 degree, E2 will be more preferred over SN2. Why? Because this hydrogen, at reaching this carbon will be very difficult for the base. Okay, so for this base reaching this carbon, that too from backside is difficult. It will just prefer to take this hydrogen. This will go, and you'll be getting this plus HC C minus. Is it clear? Yes or no?
Yeah.
Okay. After 19, in any doubts up to 22? Yes or no?
So 20.
20th. Okay. So 20th is something which we discussed in the class. Okay. So it is basically polymerization of acetylene. Okay. So if you have acetylene and you are reacting it with Cu2Cl2 and H4Cl, then one of the hydrogens will be replaced by vinyl. So you'll be getting CH2 double bond CH, C triple bond CH. If you're treating it with HCl, okay, I have told you that if the alkyne is conjugated, it will react faster because product will be a conjugated diene. This is plus and this is minus. So you'll be getting as the product. So this is like 2-chloro-1,3-butadiene. This is the chloroprene, which is what? The monomer for synthetic rubber. Is it clear? Yes or no?
Yes, sir.
Okay. Any other doubt in this question? No. Okay. Have I given this reaction that if you are using Cu2Cl2, NH4Cl, and O2 also, then you'll be getting H, C triple bond C. Have I given this reaction?
Yes, sir.
That's good. Okay. So then it is done. 20 is done, 21, 22. No doubts?
No, sir.
Okay. 23, 24.
No, sir.
25, 26.
Sir, in
Yes.
24 once can you say product B, sir?
Okay. 24, product B. You see, 24 we have to go backwards. Okay. So these are the final products. Okay. And this we are getting from the ozonolysis of D. Are you getting a point? So what will we do? We will be just joining these two groups. Yes or no? So this is the alkene whose ozonolysis will give this. Yes or no?
Yes, sir.
This alkene is formed from an alkyne through Linder's catalyst. Right? So
Yes, sir.
this is the alkyne. And you see, this alkyne is coming from a reaction of a terminal alkyne with an alkyl halide. Now, what are the possibilities? Either I have this as negative charge and here as halide, or I will have this as negative charge and here as halide. Now, which one will be more suitable? First case, you are getting a 1 degree halide. This case, you are getting a 3 degree halide. Which case the success of reaction is more? Which
1
case
degree halide.
So 1 degree. So this B should be propyl chloride and A should be this. Are you getting a point? Are you clear? Yes or no? So this part is the alkynide ion part, okay, which can act as a base, and this will be the 1 degree halide which you are talking about. So the reaction will be giving us substitution product. This can be formed from NaNH2 by reacting with this. Is it clear? Are you getting a point? Yes or no?
Yes, sir.
Okay. 26 is a doubt? Is 26 a doubt?
Yes, sir.
Sir, it's only 3, right?
No, it is asking number of moles of gaseous products. So it should
Sir,
be
like
4.
2CO2 and H2 will get no, sir.
And
3 more.
acetylene is also a gas only.
Oh, okay.
Okay. So technically the answer is 4, but there's a point here. Okay. You see, CO2 which is released will not be able to get out of the system. Are you getting a point? Why? Because CO2 is an acidic oxide. It reacts with OH minus. Okay, CO2 will react with, will be dissolved in water to form H2CO3, and it will react with QH to form K2CO3. Are you getting a point? Yes or no?
Yes, sir.
You won't get CO2 gas in this reaction. That's my point. Are you getting a point? Yes or no?
Yes, sir.
So technically speaking, CO2 should not be in the list of the gaseous products because you won't be getting it. Okay. So, but right now we should keep it at 4. Is it clear? But I'm just telling you what are the extra things which might be happening. Is it clear? Yes, no?
Yes, sir.
Okay. 26 is done. 27 and 28 and 29. I think most of the reactions. 29, the answer should be 7. all of them will be giving aromatic compounds. Okay, the answer would have been 6 if they would have asking which one of them will be giving benzene as the product. Are you getting a point?
Yes, sir.
But in that case also the answer will be 5 only, because 5 will be giving chlorobenzene. Let me just show it to you. And they have given answer as this. Okay. So in 5 they have given answer to be benzene, but the answer is chlorobenzene. Okay. So if you which of the reactions you want me to do?
Sir, consider 7.
Huh? First and 7.
Consider 7.
First and 7. Fifth is clear to you people?
No, sir. I said 7 is the answer, right?
See, first 29 first is pretty straightforward. If you have an alkane, then Al2CR2O3.
I was asking that 7 is only the answer, no, sir.
7 is also answer. But fifth is also an answer. In case of fifth, I will just discuss this question because it is a good one. Normally we discuss it in Reimer-Tiemann reaction. So you see, CHCl3 in presence of OET minus, it will give CCl2 dot. Are you getting a point? This I have discussed in the class. Yes or no? Is it clear?
Yes.
Now, this will, attack one of the double bonds and it will be forming this type of compound. Is it clear? Yes or no? Carbene addition to a double bond. Remembering this?
Yes, sir.
Now what will happen? This will hydrogen will take this will move like this, and this will move like this, and this will go out. So you see, here we have to write the numbers 1, 2, 3, 4, 5, 6. So you'll be getting a 6-member ring. 1, 2, 3, 4, 5, 6. Now chlorine is at 5th position. Okay, between 1 and 6 there is a double bond. Between 2 and 3 there is a double bond. Between 4 and 5 there is a. So actually you'll be getting chlorobenzene. Is it clear? Not benzene. Is this clear to all of you?
Yes, sir.
Okay. 29 is, so answer should be 7. All of them will be giving aromatic compounds. Okay. Other answers are okay. 30th, 31st, 32nd. Any doubts?
So once can you explain 28th?
Yeah. 28 is something which I have discussed in the doubts also. Okay. So basically, this will be an alpha elimination reaction. You have 5 C triple bond C double bond C 5 C Br and H. So you see, if you use NaNH2 or NH2 minus, it will take this hydrogen. So we have 5 C double bond C 5. Okay. So Br, you have lone pair. Now you see, you have lone pair and the leaving group on the same carbon. So what is going to happen is that here this along with its lone pair is shifting like this. Okay, this will be shifting like this. This will be going out. Okay, or let me just do it in 2 steps. It will be better. See, what is going to happen is that you have a leaving group Br here with a negative sign. This goes out, so you'll be getting something, a carbene type of species. Okay. Now, whenever you have an electron deficient species, okay, then there is always a possibility if rearrangement can take place. So we're getting 5C, triple bond C, 5. Is that clear? So the degree of unsaturation for benzene is 4, this is 2, this is 4. Total is 10. So X is 8. Is it clear?
Yes, sir.
Okay. After this, any other doubt in 27 to 32?
Sir, in 29, once explain seventh one, no, sir.
Seventh one. Okay. So in 29, seventh one. So you have a chlorine here and you have a chlorine here. So you have a hydrogen here and you have a hydrogen here. Okay, so you see, if you're using a base like OET minus, what will happen? It will cause elimination. Okay, so this hydrogen, this chlorine will go out, this hydrogen and this chlorine will go out. So you'll be getting a double one here and double one here. Is it clear? Yes or no?
Yes, sir.
Okay. 32 is done. In 32, heat of hydrogenation will be first directly proportional to number of pi bonds. So all alkynes and dienes will have more heat of hydrogenation than alkenes. And then in isomeric alkenes, less stability means more heat of hydrogenation. Okay, so I think I have given all the answers. Okay, is it clear? 32?
Yes, sir.
Okay. So 33, 34, any doubts? 33 and 34. Yes, no?
No, sir.
No doubts? Okay. I think all questions are straightforward. 35, 36. I think Weston and
Sir, in 33, can you explain RNS?
33. See, in 33, I have told you people that if you have an alkyne and you are using Hg2 plus and H2SO4, then it is basically a Markovnikov addition of H plus and OH minus. Let us say that this is delta plus and this is delta minus. Let us HC, OH, 1C, H and H. This is enol, so it will convert into keto. So you're getting HC double bond of CH3. So it is acetaldehyde. Is it clear? Now the same
Yeah,
reaction,
okay, sir.
if you are doing O3Zn, only the pi bonds will be breaking and it will be replaced by double bond O. So you'll be getting this, which is glyoxal. Is it clear?
Yes, sir.
It is known as glyoxal. Okay, 33, 34 done. 35, 36. 35 and 36. Any doubts?
Sir, for 30th question, can you draw the structure?
30th. Acrylonitrile is simply CH3 C triple bond. One minute. Acrylonitrile, no? This acetyl. Acrylo is with a vinyl cyanide. CH2 double bond CH triple bond C triple bond. So the number of pi bonds is 3. Is it clear?
Yes, sir.
Okay. Any other doubts in this paper?
So can you explain 22B?
22B. Yeah, it's similar type of reaction. Instead of HC triple bond H, you are having CH3 C triple bond H. So you want me to write the mechanism? It will be something like this. Okay, you have Cu plus, this is delta plus, delta minus. So you'll be getting CH3 C double bond CH Cu plus. This will be attacking another CH3 C triple bond CH. This is delta plus and delta minus. So if this attacks here, then what will be happening? You will be getting CH3 C double bond CH. Okay, and then C H double bond C CH3 plus. Okay, let us see. Are you getting this one? Yes or no? Now, what will happen is that this will leave, and just like the acetylene case, this triple bond will be restored. You'll be getting CH3 C let me write it like this: CH Cu double one C CH3 single bond C triple bond C CH3. And last step, this C will go out. Okay. And since copper is a metal, the bonding pair will be with carbon only. And finally, H plus UCH2 double bond C. Mm, uh, H plus mhm. It should be CH3 CH3. Okay, I think that in this case, this should be the product. Okay, 1 minute, let me just check Cu plus.
Yes, sir.
Yeah, in 31, what is the issue? You see, first you'll be getting CH3 C triple bond C minus, and then it will be reacting with CH3 C double bond O CH3. So basically this will attack here and this will go like this. So you're getting CH3 C triple bond C CO minus CH3, CH3. This will take an H plus, so it will be forming basically OH here. And if you use concentrated H2 as the 4, it will undergo elimination of water. So, 1 minute, there is background noise. Okay. Yeah, so OH and H will be going out. So we're getting CH3, C triple bond C, C, CH3, double bond CH2. Is it clear? So the degree of unsaturation will be 2 plus 1, 3. Okay. Degree of unsaturation of 5. They are giving it as 4. Should be 3 only, I guess. 1 minute, let me check. 31. So I have given answer wrong. In case of 31, if you are talking about degree of unsaturation, then the answer should be 3. Are you getting a point?
Yes, sir.
Okay. Any other question in this paper? Yes. No. I would request every one of you to switch off your video feeds. Okay. Any other doubt in this paper? Yes or no? Any other doubt?
Sir, 25th question, sixth reaction.
Sixth reaction. Yeah, this won't take place because it is not a good base. Are you getting a point? You need a base which is stronger than, like you see, the negative charge will be more stable on oxygen compared to sp carbon. Are you getting a point? If you're writing the product. Are you getting a point? Yes or no?
Yes, sir.
Okay. Any other doubt in this paper? Yes, no. Mechanism wise, the answer is not coming, so I have to look into check the mechanism again. Okay. But apart from that, other questions are good in this paper. So, is this paper done? Yes, no. Any other doubt in this advanced paper?
Sir, can you explain the reactions in 26th?
26th. Yeah.
Sorry,
Yes.
25th, sir.
20?
5.
Which one?
25. Can you
Which
explain
reaction?
the products in those, like why those are not feasible?
See, the principle is that a reaction is feasible, then you will get more stable products. So if you are writing products, okay, You can always write the products plus H2O. Here you can write as S3 triple bond C minus plus Cu2H5OH. Here you can write it as HC triple bond C minus plus NH3. Okay, here you can write SC triple bond C minus plus CH4. Okay, here you can write it as HC triple bond C minus plus CH3COH. Others I have written. Now you see, always remember that the stability order of negative charge is O minus more than stable than CSP, then N minus, then you see C minus. Are you getting a point?
Yes.
So if it is more stable, then the product will be more stable. So you see, in all cases, the negative charge is shifting from oxygen to carbon, Sp, which is less stable. So this reaction won't be feasible. Are you getting a point?
Yes.
Yes or no? So that way you can explain most of the thing. Is it clear?
Yes, sir.
Okay. Any other doubts in this paper? Any other doubts in this paper? I think more or less this paper is done. Yes or no? Is this
Yes, sir.
okay? So with this, I'm ending this paper discussion. Okay. So I'm stopping the